Hello everyone, welcome to the video lecture series on 8086 microprocessor, and today's topic is pin diagram of 8086. So as we all know, 8086 is a 40 pin microprocessor, and this is the advanced version of 8085. So here, as per the diagram, you can see that there are 40 pins altogether. Starting from 1, it has went down to 20, and again from 21, it is to 40. So to read out from pin 1, which is called as ground, as we all know, ground is nothing but the value is going to be 0. And from pin number 2 to pin number 16, which in the other words can be said as AD0 to AD14. So there are pins, that is 15 pins starting from 0 to 14, from pin number 16 to 2, and these pins, the arrow marks are represented bidirectional, meaning that AD0 to AD15, it is bidirectional pin, and AD stands for address slash data bus. Generally, the lower order address bus, these are, and are multiplexed with data. When AD lines are used to transmit memory address, the symbol A is used instead of AD. For example, A0 to A15, meaning that only the memory address are being transmitted. Say for instance, if other than using address, if a data is used, these pins will be represented as D instead of AD or A, and it stands for D0, D1, D2, etc. to D7, or D18, 8 to D15, or D0 to D15, depending upon the value or the bits which we need to transfer. So here you can clearly see that the pin number starting from 16 to 2 represents AD0 to AD14, and another one pin which is in 39 is represented as AD15. So here right from AD0, AD14 to AD15, which is in 39th pin, everything does the value or does the operation of carrying the address or data. So when it is address, it is represented as A rather than AD. And when it is data, it is represented as D rather than AD or A. So apart from this, you can see AD pins from pin number 35 to pin number 38, and it is also represented as AD16 slash S3, AD17 slash S4, and AD18 slash S5, and AD19 slash S6. So these are the higher order buses, and these are multiplexed with status signal, whereas we saw that pins from A0 to A15 or AD0 to AD15 are all lower order address bus, and these are just multiplexed with data, and they are not multiplexed with status. Whereas coming to the higher order buses, we can see that from AD16 till AD19, they are higher order buses and are multiplexed with status signal. So now moving to the next common type of signals. Here you can see that BHE, where we can speak about the order bars later. So BHE generally stands for bus high enable status. So BHE active low slash S7, which is the output. And this pin is generally used to enable data on the most significant half of the data bus. So D8 to D15. So that is the most significant bit, and hence D8 to D15, it can signify the data bus. So 8-bit, this is an 8-bit device connected to the upper half of the data bus uses BHE, that is active low signal. It is multiplexed with status signal S7. So now coming to the next common signal, which is nothing but MN/MX, which is in pin number 33. So here you can see right from pin number 1 to 16 we have already seen, and 20, as we all know, it is ground. And now come from 39 till 34 we have already seen. So now coming to pin number 33, which is minimum maximum. So this pin signal indicates what mode the processor is to operate in. That is either in minimum mode or in the maximum mode. And in detail about these minimum and maximum modes, we can see in the upcoming videos. So now coming to the next pin, which is nothing but RD, that is in pin number 32. So RD, as we all know, it is generally read, and this is always active low. This signal is used for a read operation. It is an output signal and it is active when it is low. So the low means 1 here, and when it is high, it is 0, because a bar is represented here. So everything will be reversed, meaning that active low, meaning when it is active, it will be 0. So now moving to the other pins. So coming to the pin number 23, you can see test pin. So the test pin is tested by the wait instruction. So 8086 will enter a wait state after the execution of the wait instruction and will resume execution only when test is made low by an active hardware. So this is used to synchronize an external activity to the processor internal operation. So generally, whenever we do some operation, after the operation, we have to wait and check whether the operation is complete or the operation can be moved to the next phase. So that is the primary motto of this test pin. So this test pin generally checks whether the function is over or the instruction or the execution of the signal is done. So now moving to the next one. So this is the ready pin, which is in pin number 22. So this is the acknowledgement from the slow device or the memory that they have completed the data transfer. The signal made available by the devices is synchronized by the 8284A clock generator to provide ready input to 8086. This signal is active high. So here, when speaking about test and ready, you can see that test is represented as active low and ready is represented as active high, because test here is given as test bar and ready is just ready. So when test is okay, that is test is done, it means that 0 signal will be given. And when there is an acknowledgement that the data transfer is complete, it will be represented with the value 1. So this is generally about the test and the ready pins. So now moving to the next pins, which is nothing but the reset pin, the clock pin, and the interrupt request. And we can readily say that reset in pin number 21 causes the processor to immediately terminate any action, whichever is happening. And the clock input. The clock input provides the basic timing to the processor operation and bus control activity. It is generally an asymmetric square wave with 33% of duty cycle. So now speaking about the interrupt request. This is a triggered input and this is sampled during the last clock cycles of each instruction to determine the availability of the request. If any interrupt request is pending, the processor enters the interrupt acknowledge cycle, and this signal is generally active high and internally synchronized. So the interrupt request is given in pin number 18 and the clock. CLK. So I have a question. So in which pin number is CLK available? So can you check from the pin diagram and can you answer? Yes, it is in pin number 90. And reset, which pin number does it lies? Yes, it lies in pin number 21. So now in the forthcoming videos, we'll move into the minimum and the maximum modes. So let us discuss about that in deeper later. Thank you.